Hi, I'm Dan Toomey, and in this webcast, we will be demonstrating how easy it is to integrate BizTalk Server 2013 with Windows Azure Service Bus queues and topics, facilitating the creation of powerful hybrid applications. To begin with, we should mention the main features of Windows Azure Service Bus. Essentially, the Service Bus provides a rich set of tools to support both connectivity via the cloud, using relays and protocol tunnel eventing, as well as pub-sub messaging structures, including queues and topics to enable integration. It supports reliable transfer, routing through filters, and even some primitive transformation. While BizTalk 2013 provides ample support for Service Bus relays, the subject of this presentation is limited to integrating with queues and topics only. Service Bus queues are a cloud-based version of the same queues we are used to working with in any other programming model. They are essentially first-in, first-out data structures that have one sender and one receiver. They are great for load leveling and offline batching. Queue messages are made up of a collection of properties which are just key value pairs and may include an optional body. Note that the body is opaque, meaning it is not exposed to the broker. Topics differ from queues in that they support multiple subscribers, so more than one receiver can get the same message. It is essentially a publish-subscribe model not very different in concept from the BizTalk messaging engine. Filters can be used to target messages to individual subscribers. There is also support for filter actions that actually modify, add, or remove properties as the message is selected. So in that, we have a limited transformation capability. Everything in Service Bus starts with a namespace. The root of the namespace is always the same. It is your app name followed by servicebus.windows.net. However, this namespace tree can have as many leaves as you wish. Well, at least up to 32 segments and/or a 450 path character limit. The best thing is that each leaf can be individually maintained and secured with access control services. Each Service Bus namespace has a shadow in ACS, which allows you to configure users, roles, and policies. ACS works by claims, and identities are federated by ACS providers, such as Google, Facebook, Yahoo, LiveID, etc. Claims are mapped to rights for each realm. BizTalk Server 2013 included a number of new enhancements and adapters to facilitate integration with the cloud. In fact, a major focus of this release was to make it easier to build hybrid applications. That is, applications that utilize on-premises systems but still leverage the cloud to support greater connectivity and elasticity. The adapter we will focus on in this presentation is the SB messaging adapter. This adapter enables you to easily connect to existing Service Bus queues and topics. All you need at a minimum is the URL and the ACS details for authentication. There are also some additional properties that enable you to control how the message properties are written or promoted to the BizTalk message context. Let's look at the send adapter first. In this mode, the minimum settings are the URL to the Service Bus resource, which you specify on the first tab, and the ACS namespace and credentials used to authenticate to the resource. You also have the option to explicitly specify some default brokered message properties, as well as provide a namespace corresponding to any BizTalk context properties that you want added to the brokered messages users properties. Note that this is not the namespace used to write them into the Service Bus message. It is used only to retrieve context properties from the BizTalk message. The receive mode of the adapter is very similar, with just a few subtle differences. You still need to provide the mandatory URL and ACS credentials, of course. The main difference is in the option to add user-defined brokered message properties to the BizTalk message context. Note that standard brokered message properties are already written to the context, although not promoted, so including this namespace will add the user-defined ones as well. You can also choose to promote them, but be aware that you need to have all the brokered message properties defined in a property schema, or you'll get runtime errors. The final difference is that the receive mode of the adapter allows you to specify whether or not to use a session when retrieving messages. If your queue or topic has been configured to support sessions, this setting allows you to pull a group of related messages all at once. Let's have a closer look at the URL that we use to point to our queues and topics. As mentioned previously, all Service Bus addresses have the same format. They start with the SB protocol and have a base address that consists of your custom namespace token followed by the standard servicebus.windows.net tokens. What follows varies depending on whether you're pointing to a queue or a topic subscription. If it's a queue, then it is simply the path to the queue, which may be right at the root level or may be nested under several levels, but always ending with the queue name. For topics, it's a little bit different. All topics must have at least one subscription, so the path must end in a series of 3 tokens: the topic name, the constant subscriptions, and the subscription name. Finally, regarding the namespaces for brokered message properties, it is important to realize that there are only 2 namespaces involved here. The first is the namespace that is used for all the standard message properties, the ones that are included with every brokered message. For example, sequence number, time to live, and content type. The other namespace will be used for any user-defined properties that you decide to include by promoting your BizTalk context properties to the Service Bus message when you write it to a queue or topic subscription. It doesn't matter what namespace is used in the BizTalk message context. When you include them in the brokered message, they will always be assigned this user namespace. Now it's time for our first demo, where we will show how easy it is to connect to a Windows Azure Service Bus queue using the BizTalk 2013 SB messaging adapter. In fact, it is so easy we won't even need to crack open Visual Studio for this demonstration. Now the first thing we have to do, of course, is actually create the queue in Azure that we're going to connect to. So here I have a Service Bus namespace defined. It's called BizTalk. And before I leave this screen, I'm just going to grab the connection information because I need to copy the key here so that I can use it later. Now I'm going to go into queues, and we'll see that currently I have no queues. So I'm simply going to add one by clicking New, Queue, and we'll do the Quick Create option. And I'll give it a nice original name. And we'll accept the default values and just say Create New Queue. It should only take a few seconds to do that. And there we are. We've successfully created our queue. Now what we're going to do is create a very simple BizTalk application that's simply going to read a file from the file system, write it to the Service Bus queue, read it back from the Service Bus queue, and write it back to the file system. Not a very useful application, agreed, but it does show us how simple it is for BizTalk to communicate with a Service Bus queue, and we're not going to have to write a single line of code or even open Visual Studio. So the first thing we're going to do is simply create a new application. We'll call it SB Messaging Demo. And in that application, we're going to start by creating our receive ports. Now first, obviously, I'm going to need a receive port to actually read it off the file system. So we'll simply use the file adapter for that. We create a receive location. And I've already got a folder defined for that. Done. Now, after we've actually written the message to the queue, we're going to want to receive it from the queue and write it back to the file system. So I'm going to need another one-way receive port. We'll call this SB receive port. And for this receive location, we're going to use the SB messaging adapter. Now, very simple configuration. Obviously, I need to give it the Service Bus namespace, so I just have to type my application name in there, and then I also have to type the name of the queue that I'm going to read from. I also have to provide my ACS authentication credentials. So again, the application name is the same, BizTalk, and the issuer name I know is owner, and now I'm going to paste in that key that I copied before. That's all I have to do. So I'm going to click OK, and there we've configured the adapter that's actually going to read from the Service Bus queue. Now, of course, I have to write it there first. So I'm now going to create a send port, and we're going to do a static one-way send port, and this one is going to send the message to the queue that we received from the file system. So again, I'm going to choose the SB messaging adapter, And you'll notice that the configuration in send mode is very similar to the configuration in receive mode. Again, I have to specify the application name in the namespace, and of course the queue name that I'm writing to. And of course I also have to give my ACS credentials. Looks exactly the same. Now I could also decide to promote some properties in that message, but we're just going to accept the default right now. Almost forgot. In order to pick up the message that we receive from the file system, I'm going to have to create a subscription in this port to read from that receive location. So I'm simply going to use the BTS properties receive port name and put in the name of the receive port that's actually reading the file from the file system. And that was message receive port. There we go. Now, once I've sent the message to the queue and then retrieved it with the receive location I previously created, I'm going to have something to subscribe to that message, otherwise I'll get a persistence error in BizTalk. So I'm just going to create another one-way send port that's simply going to write the message back to the file system. So we'll call this send from queue, and it will be using the file adapter. And again, I've got a folder defined for that. And we'll just call it dequeued. Now, likewise, I'll have to create a subscription based on the receive port name. And that, of course, was SB receive port. Now that's it. Now, I'm going to start the send port that actually writes to the queue, because we definitely want to do that straight away. But I'm going to leave only enlisted the port that actually writes to the file system. And the reason is that once we dequeue the message from Azure, I want to actually have a chance to look at it and look at its context properties in the BizTalk admin console before it actually goes straight through. So by leaving this stopped, enlisted but stopped, the message will be in a holding pattern for us so that we can inspect it. Likewise, on the receive locations, I'm definitely going to enable the receive location that accepts the file from the file system, because that's the only way we'll get this thing started. But I'm going to leave disabled the port that actually reads it from the queue. This way we can actually look at the queue in Azure and make sure that we've actually successfully written the message before we just read it out and dequeue it straight away. So now, the next thing is simply to write a message to the queue. So I'm going to take this sample queue message, which is just a tiny bit of XML. It doesn't have to be XML, by the way. It could be anything. It could be plain text. It could even be a binary file. The payload of the queue doesn't matter. So we'll simply take this and drop it into the int folder. And now, if we go back into the queue in Azure, we've just witnessed the queue length change from 0 to 1. So we have successfully written the message to the queue from BizTalk. Now we'll go back into BizTalk and we'll enable that receive location so that we can now dequeue the message. And going back into the Azure portal, we should see that queue length change from 1 to 0, which it just has. So we'll go back into BizTalk and we should see the message suspended here. And the reason it's suspended is simply because that send port that does subscribe to it is stopped. So it's simply waiting for it to be started so that it can send the message back to the file system. But this gives us an opportunity to actually look at the message. And what I wanted to show you was that first, here's the message body. So we know that we got back what we put in the queue. Looks exactly the same. And I wanted to show you the context properties. If we expand the namespace here, you'll see that we get all our usual BizTalk context properties. But towards the end here, you'll see that we also get a bunch of brokered message properties. So by default, all of the standard context properties that Azure Service Bus provides are written to the context of the BizTalk message. So we have content type, delivery count, and queued time. Notice though that none of them are actually promoted except for the sequence number. And that's simply done so I think it can aid in doing order delivery. Now that we've had a look at the message, we can go back and enable that final send port and write the message back to the file system. So we'll start that, and we should see the message appear in our out folder, and there it is. So in this demo, we've effectively demonstrated that within minutes, we can create an application that both reads and writes to Windows Azure Service Bus queues using the SB messaging adapter that comes in BizTalk 2013. And we did it all without writing a single line of code. In this second demo, we will show how easy it is to connect to a Windows Azure Service Bus topic using the BizTalk 2013 SB messaging adapter. For this one, we will demonstrate some more advanced features, including custom property promotion and filtering subscriptions. Now, because we're going to be promoting some custom user properties, we need a Visual Studio solution this time because we have to deploy a BizTalk property schema in order to make properties available to be promoted. So here in this solution, I have a very simple client request schema that contains 3 properties, 2 of which are promoted, including an order amount field. And here's the property schema that specifies those 2. We'll just deploy that solution now. Terrific. Now, if you have installed the Windows Azure Service Bus SDK for .NET, you get a really cool feature in the Server Explorer. You have the ability now to browse Service Bus artifacts here in Visual Studio without having to rely on the management console in your browser. So here we can see my namespace for BizTalk. We can see my original test queue that I created for the first demo, but I've also created a topic called Client Orders. And that topic has 2 subscriptions, a high order amount and a low order amount. Each subscription comes with a set of rules. Now, initially, there's a default rule created which simply has a property that 1 equals 1. We're going to create a new custom rule here, and we're going to call it high order amount. And the rule is simply going to say order amount is greater than or equal to 1,000. Now, order amount is a custom property, and you'll notice it's exactly the same name as the property that I've promoted in my BizTalk message. So we're going to have to find a way to add that property to the context of the brokered message before we submit it to the topic. So we'll click OK. And now we're going to create a similar rule for the low order amount. In this case, it's going to be order amount is less than 1,000. Now, we'll have to delete the default rules that are there because otherwise every message will fulfill both subscriptions. There we go. Now let's have a look at that BizTalk application. First, I'm going to refresh the group and then restart the BizTalk host instance, which is something we should always do anytime we have a fresh deployment. Next, I'm going to import a binding file that I've previously created so that you don't have to watch me create those send and receive ports manually. Now let's look at the send port that actually writes to the Service Bus topic. You'll see that again we're using the SB messaging adapter, and you'll see that it looks very much the same as when we were writing to a queue. The only difference here is that we're actually specifying the topic name instead of the queue name. Now I still have to provide my authentication credentials to ACS, and binding files never store sensitive information like passwords or issuer keys, so I'll have to paste that in here from what I already have in my clipboard. There is one difference though. In this case, if we go to the Properties tab, you'll see that I've specified a namespace for user-defined brokered message properties. This is the namespace from that property schema that I deployed. What this is saying is that go to the context of the message and any promoted properties that have this namespace, write to the user properties of the brokered message. Now it's important to realize that this namespace is not the one that will actually be in the brokered message. The namespace that will be used for these properties is that brokered message user namespace that we saw previously on one of the slides. So I'll save this change. Now let's look at the receive locations. And you'll see here that I've got 2 receive locations pulling from that topic. And the reason is that we have 2 subscriptions. With topics, the receive locations actually don't subscribe to the topic, they subscribe to a specific subscription. So because we had 2 subscriptions, we have 2 receive locations. And each one of these is configured, again, the same way as for queues, except that we now specify the topic name, we have a subscriptions token, and then we have the actual subscription after that. And of course we have to put in our ACS credentials. So I'm going to paste that in, and for the other one as well. Now the last thing we'll look at is the send port that I've created for each one of those receive locations so that we can write the message that we retrieve from the topic out to the file system. So again, I just have a filter that binds on the inbound transport location. So now all we have to do is start the application, and then we're ready to test. Now I've created 2 request messages here, one with a high amount of 20,000 and one with a low amount. We'll do the low amount first. I'm going to submit that in my in folder, and hopefully I should see it appear before long in my low orders output folder. And there it is. Now we'll do the same with the high amount. And that should appear down here, which it does. So now that we know that that's working, I want to just go in here and disable these 2 send ports, because we're going to submit again, and I want to trap the message in BizTalk so that you can actually look at the context properties. So we'll submit another one, and then go back to the BizTalk administration console, and we'll look in the group, and we should see a suspended message here. Here is the message that is waiting to be picked up by that send port and written to the file system, and this allows us to go in and look at the context properties of that message. There's the message body, and in the context, and I'll just expand this window and expand the namespace column, and we'll see that we have the same set of standard brokered message properties that we had when we wrote to the queue before. But we also have 2 properties that are written to the user namespace in the brokered message. And these, of course, correspond to the exact 2 properties that we promoted from the BizTalk context when we wrote the message to the topic. So this is what's enabled filtering on those properties. Here are some useful references for both Windows Azure Service Bus and also for BizTalk Server 2013 and its ability to integrate with Service Bus queues and topics via the new SB messaging adapter. I hope you have found this webcast useful and informative. Please also take some time to visit our user group's web portal, where you'll find plenty of other links and resources. If you decide to join, membership is free, you'll not only have access to more areas of the portal, including downloads of presentations and code samples, but you'll also receive event notifications and newsletters from BizTalk. I promise you won't be spammed, and you can always unsubscribe if you change your mind. You can also find us on Facebook or follow us on Twitter. Again, I'm Dan Toomey, and I want to thank you for listening to this webcast. If you have any comments or questions, please feel free to use the YouTube comment stream for this.